Hi, hello, namaste. Today we are going to discuss about halogenation of benzene. So, halogenation, halogenation of benzene, halogenation of benzene. So, what is the reaction involved in it? Benzene reacts with benzene reacts with with halogen halogens in the presence of in the presence of Lewis acid. Lewis acid. What are Lewis acid? Either may be AlX3 or FeX3. FeX3, which gives gives halobenzene halobenzene as product. Halobenzene as product is known as halogenation of the benzene. So benzene reacts with halogen in the presence of AlX3 or FeX3 and which gives it halobenzene as a product. Halobenzene as a product. This is the mechanism involved in it. Benzene. This is the mechanism involved in it. Then the X equals to chlorine and bromine. So this is the reaction involved in the halogenation of the benzene. So what is the mechanism involved in it? We'll see. So, in the mechanism, there are three steps involved. First one is the mechanism. So, in the mechanism, three steps are involved. First one is the production of, either maybe generation of halonium ion. Generation of the halogen ion. So these halogens undergo homolytic dissociation, either maybe in the presence of Al, they are thinking AlX3 and this electronegative atom which will be captured by this AlX3 and it will be converted into X plus ion, that is the halonium ion and plus AlX4 minus and Al plus will be formed. This halonium ion will be formed. In the second step, attack of halonium ion on pi electron system of benzene. So the benzene structure will be like this. The benzene undergoes this halonization. It means in the presence of this electrophile halonium ion. When these bonds are shifted towards this carbon atom, the carbon atom gets negative charge and this carbon atom gets positive charge. Same double bond system will be present over here. Then this in the presence of this halogen ion. So this halogen ion positive charge. So this negative charge will be attack this halogen ion and it will be converted into halobenzene. So halogen will be formed over here and this hydrogen will be present over here and it will be positive charge over here and double bond system will be present over here, double bond system will be present over here. To neutralize the positive charge, the electrons are shifted towards this carbon atom and it will be converted into this product, this derivative. So X will be formed here, hydrogen will be formed here and this to neutralize this positive charge will be neutralized by this bond. Hence double bond system will be formed over here and positive charge will be formed over here and double bond system will be present over here. Then coming to neutralize this positive charge. This double bond will be shifted towards this single bond and it will be converted into this product. So that is and X over here. So hence this bond double bond system will be present. To neutralize this positive charge, these electrons are shifted. So the double bond system will be present here. Then this bond lost. So the positive charge will becomes over here. So this is the end. So then by this one it will be loses the proton to get the aromaticity. This halobenzene, substituted halobenzene loses the proton and it gets the aromaticity. That is the third step. What is the third step? That is the loss of proton. Loss of proton or the restoring of aromaticity. So that is the third step is the loss of proton or restoring aromaticity. So this is the third step, which is the third step involved in it. So what is the thing? The benzene. So the benzene, the H will be formed, X will be attacked here, hydrogen will be present here, the double bond system will be present here, double bond system will be present here, and here the positive charge will be present. This is the last step, that is the loss of the proton. So this benzene loses one proton and it will be converted into halobenzene as a product. So H double bond and double bond system will becomes here and this product will be formed. So here the H plus ion will be released. So this released H plus ion reacts with Al X4 minus and Al plus and it will be dissociate into HX and this Al X3 automatically Lewis acid will be released. Why? Because this Lewis acid act as a catalyst. So this is the reaction and mechanism involved in the hallucination of the benzene. So if you like my video, please like it. If you want to get notification about my videos, please subscribe my channel JB Chem Tutorial. If you want any explanation about topic, please comment topic name in the comment section. Thank you one and all.